We're going to talk about scalars and vectors today, two very important quantities that are used in measurement in physics. Let's consider first of all scalars. Scalars are quantities that we use every day. You would be quite familiar with some of these. Examples of scalars would be temperature, for example 30 degrees Celsius, 75 degrees Fahrenheit. Everyday sorts of temperatures which we measure with a value and a unit. Another example of a scalar quantity is pressure, the air pressure that we measure atmospheric pressure in, so we can tell when a storm is coming. One of the highest ever recorded atmospheric pressures was 1085 hectopascals. Now, don't worry about this unit, it's just a way of measuring pressure, hectopascals. That's equivalent to 32 inches of mercury. That's what most of the world regard as the old way of measuring pressure. That's a high pressure, a very low pressure, one of the lowest pressures recorded not in a tornado situation, was about 870 hectopascals. Again, don't worry about this unit, and in some parts of the world this would be the equivalent to 25.7 inches of mercury. So again, we've got a quantity, an amount, 1085, and a unit, hectopascals, or inches of mercury. Let's do one more. Age. Age is a scalar quantity. So some baby might be 2 days old. 2 days old. So we've got a quantity, 2, and a unit, days old. Most of us are not 2 days old, and we need to measure age in a bigger quantity than that. So somebody might be 15 years old. But you see the idea here, that we've got a unit and we've got a quantity. A quantity and a unit. That's the property that scalars have. There are two things about scalars that we must have. One is that they have a size. So in our examples here, 30, 75, 2, all these were the sizes of what we were measuring. And they have another thing, they have a unit which tells us the type of measurement we're making. And so we had degrees Celsius, degrees Fahrenheit, hectopascals, this strange unit, hectopascals, or inches of mercury, or the more common days old or years old as our units. Now I want to look at something a little bit different to this. I want to have a look at a thing that in physics are called vectors. Now vectors are extremely important in physics. You're going to hear about vectors throughout your physics careers. Some examples of vectors: velocity, an example of a velocity would be, let's suppose we've got some object and this object is moving at 10 meters per second and it's moving to the right. So we would say that the velocity of this object is 10 meters per second to the right. Here we've got another one. And the velocity of this object is 15 meters per second to the left. So you can see that it's a bit more complicated than with scalars, where we just had to give the number and the unit. Here we've got to give a direction as well, and this is the thing that marks vectors as different to scalars. Third example, we've got some object and it's falling at 25 meters per second, and it's falling down, so moving down, not up. Now the thing about these vectors then is that we can see that unlike scalars, there's an additional thing that we have to worry about. Certainly a vector has a size exactly the same as a scalar does. It also has a unit in exactly the same way that a scalar does. But a vector, different to a scalar, also has a direction. And this is the thing that marks vectors as completely different quantities to scalars. However, they have, all of these vector quantities that we've drawn here have a counterpart in scalars, and that counterpart is speed. Speed is a scalar quantity because speed only requires a number. In this case it would be 10 meters per second, and a unit. So a number 10 and a unit meters per second to tell us how that measurement is being made. And it doesn't tell us which direction the object is moving in, so we don't know very much about it. It's not very useful, as you can see, because we don't know if it's moving towards us, away from us, if it's travelling very fast and we need to get out of the way. Speed is not as useful as velocity, which tells us which way the object is moving. In the case of our example of 15 meters per second to the left, the speed would be described simply as 15 meters per second with no direction. Again, no direction, just the size and the unit would be given to us. And the same with the one that was falling, we would have as a speed 25 meters per second with no direction whatsoever. We would have no idea if it's moving up or down or in any other direction. So this is the difference between vectors and scalar quantities. Our scalar quantities, we need to have a size and a unit to designate a scalar quantity, but for a vector quantity we must have a size, a unit and a direction. And that's the only difference between them. It sounds quite complicated when you start to talk about scalars and vectors. If you want to impress your friends, you throw these words around and you'll sound very knowledgeable, but you and I both know now that they're actually quite simple quantities. The only difference is that vectors have a direction and scalars do not.